Okay, let's jump in. Today we're taking a deep dive into Phillip Island in Australia. It's often held up as, well, maybe the gold standard for wildlife conservation.
It really is a fascinating place. It's sort of ground zero for figuring out how to bring species back and make it stick.
Right. And our mission here is to kind of unpack how they do it. What are the actual mechanics behind their success? What can we learn?
Yeah, exactly. And Phillip Island's location, down in the Bass Strait between Victoria and Tasmania, makes it this incredible hub for all sorts of life. Marine, land animals, birds. We're really looking for those aha moments in their conservation approach. It's very data-driven.
And the results speak for themselves, don't they? I mean, you've got huge numbers of little penguins, massive colonies of fur seals,
Some of the biggest in the world, yeah.
and even marsupials coming back after being locally extinct. It's quite the range.
Yeah, it really is, from the big marine mammals right down to some quite unique terrestrial critters.
Okay, let's start out in the water then, with the Australian fur seals at Seal Rock. You said one of the largest congregations.
Definitely. We're talking around 30,000 animals there, maybe 4,000 pups born each year. It's huge.
Wow. And the total monitored population is something like 80,000. How on earth do you keep track of that many seals? That seems like a massive challenge.
It absolutely is. And that's where their conservation model really starts to show its cleverness.
Okay.
They rely heavily on technology, specifically drones. They have this great phrase for it, looking without landing.
Looking without landing. I like that. So minimal disturbance.
Precisely. The drones fly high enough to get detailed counts and observations, but without stressing the seals, especially during breeding season. That's critical.
Right. So it's not just about counting heads, is it? You mentioned understanding the ecosystem.
Yeah, and this part is fascinating. They figure out what the seals are eating and therefore the health of the whole food web by collecting their scats.
Their poo.
Basically, yeah, seal feces. They've been doing this since 1997.
Wow, that's long-term data.
It is. And inside the scats, they find the hard bits, fish bones, squid beaks, octopus beaks. That tells them exactly what's on the menu.
So this long-term scat collection, it gives you a snapshot of what they ate. But how does that translate into, like, real-world conservation action?
Well, it creates this incredible timeline of the marine ecosystem. If the diet suddenly changes or the type of prey shifts, it signals something bigger is happening out there.
Okay.
And these seals, they're amazing hunters. They're actually more closely related to sea lions, so they're agile on land, have external ears.
Right, not like true seals.
Exactly. They have these two incredibly thick layers of fur for insulation and hydrodynamics, and their whiskers. They're something else.
How so?
Apparently 14 times more sensitive than a cat's whisker. They can feel the tiniest water movements to track fish, even in murky water.
Incredible. So they're well-equipped, but they still face threats, obviously. Sharks.
Oh yeah, great whites are a big one. They use their agility and often hunt cooperatively in big groups to try and evade them. But the bigger threat now, it's environmental.
You mean climate change?
Yes, specifically rising sea temperatures. The Tasman Sea around there has warmed about 3 degrees Celsius recently.
3 degrees. That sounds like a lot for an ocean.
It is, and warm water holds fewer nutrients. This
Right.
is causing kelp forest crucial habitats to vanish.
And the kelp is where the fish are.
Exactly. So fewer fish locally means the seals, especially the nursing mothers, have to travel much, much farther to find food, sometimes up to 200 kilometers further.
Wow. And that must impact the pups waiting back on the rocks.
Hugely. Less food for the pups means lower survival rates. So the seals, they really act as an alarm bell for the whole marine environment's health.
Okay, so the seals are facing ocean changes. Let's pivot to the shore, to maybe the island's most famous residents, the little penguins.
Ah, yes, the fairy penguins. Smallest penguin species, only about 33 centimeters tall.
Their story is often cited as a huge conservation win, right? Wasn't there a big issue maybe 30 years ago?
There was. High mortality rates, mainly from cars and habitat loss as housing encroached on their nesting areas. It got pretty bad.
And the solution was quite radical.
It really was a massive land buyback program. Essentially, they bought back coastal properties to return the habitat to the penguins. That initiative really kickstarted everything else on the island.
A huge investment. But like the seals, they're not immune to climate change now.
No, unfortunately. The same problem, really. Their food sources, small fish and squid, are moving because of the warmer waters. So they have to work much harder, swim further, dive deeper.
And researchers are tracking this effort. I read something about penguin Fitbits.
Sort of, yeah. They use tiny microchips and GPS trackers attached to the penguins.
Uh-huh.
And the data coming back is just astounding. You've got this little bird doing maybe 2,000, even 2,500 dives in a single day at sea.
2,500 dives.
Yeah, sometimes down to 70 meters deep. It shows the incredible physiological effort involved in just surviving day to day now.
And all that effort culminates in the famous penguin parade spectacle.
That's right. They're the only truly nocturnal penguin species when on land. They wait out at sea until it's properly dark.
Why wait?
Camouflage. That classic penguin coloring dark blue back, white belly works best as counter shading against predators from above and below, especially in low light. So they wait for darkness, then come ashore all together in big groups or rafts.
Safety in numbers.
Yeah.
And their walk, that famous waddle, there's a reason for that too.
There is. It looks inefficient, but it's actually very energy saving on land. Their knees are essentially fused straight.
Really?
Yeah, so they save energy by just leaning forward and sort of letting gravity help them tumble along. It conserves energy they desperately need for hunting.
Clever biomechanics.
Mm.
And speaking of energy, what about the molt? I heard it's pretty extreme.
Oh, it's incredible. They have to replace all 10,000 of their feathers every year.
10,000.
Dense, overlapping feathers for waterproofing. But during the molt, they lose that waterproofing, so they absolutely cannot go in the water to hunt for about 2 or 3 weeks.
So they have to starve.
They prepare for it, they gorge themselves beforehand, eating huge amounts. They can go from their normal weight of about 1 kilogram up to 2.5 kilograms.
Wow, gaining 150% of their body weight.
Yeah, just packing on the fat reserves to survive those few weeks fasting on land while the new feathers grow in. It's an amazing biological cycle.
And reproduction-wise, they're quite prolific for penguins.
They are usually lay 2 eggs per clutch, but uniquely, if conditions are really good, lots of food, good weather, they can potentially lay up to 6 clutches in a season.
6. That's unusual.
Very. And finding their mate and nest burrow in a colony of thousands of noisy penguins, they rely on very specific individual calls, like a unique voice signature.
A very vocal colony, I imagine. Okay, let's move inland. The land-based conservation stories seem just as impressive, especially with predator control.
Absolutely. The eastern barred bandicoot is a prime example.
Right, this is the one that was almost wiped out on the mainland.
Exactly. Primarily due to introduced predators like foxes and feral cats. Phillip Island offered a potential refuge.
And the key was getting rid of those predators.
Completely. A really targeted, sustained effort to eradicate foxes and feral cats, plus a strict ban on domestic dogs on the island.
And it worked.
Dramatically. The bandicoot population went from maybe fewer than 100 individuals to around 300 in just 5 years.
A 300% jump in 5 years. That's definitive proof of the impact of predator removal.
It really is. Clean cause and effect. And the bandicoots themselves are pretty cool little animals, nocturnal, using those sensitive snouts to dig for worms and insects.
And they have that distinctive run.
Yeah, kind of a wonky run, people call it. They have long hind legs, a bit like a tiny kangaroo, which helps them sort of bound away from trouble quickly.
Huh. And didn't someone name an ancient relative after a video game character?
They did. A newly described fossil genus related to bandicoots was named Crash back in 2014. A little paleontological humor.
Love it. Okay, what about koalas? We see them at the Koala Conservation Reserve there.
Yes, and they're a fascinating case of survival through specialization. They eat vast quantities of eucalyptus leaves, up to 0.5 kilogram a day.
Which are famously tough and, well, toxic to most animals.
Precisely. Those toxins make the koala's own body tissue taste awful to most potential predators. It's a built-in defense mechanism.
So eating poison protects them.
In a way, yes. And they need highly specialized teeth to handle it, sharp incisors at the front for snipping leaves, and really powerful molars at the back for grinding down the tough fibers.
Incredible adaptation. Any other interesting island residents we should mention?
Well, there's the Cape Barren goose, which has this neat trick of being able to drink salt water during the dry breeding season if fresh water is scarce.
Handy skill to have.
And we can't forget the Australian white ibis.
Ah, the infamous bin chicken.
Hey, yeah. Their huge urban population boom is actually quite recent, apparently starting around the 1970s. The theory is exposure to captive or zoo flocks made them lose their natural shyness around humans.
And discover the joys of discarded fast food.
Pretty much. Leading to their current reputation in many coastal cities.
Okay, so pulling it all together, what's the core message from the Phillip Island model?
I think it demonstrates very clearly that real conservation success is possible, but it requires a specific combination of things.
Right.
Targeted programs tackling the root causes like predator eradication, habitat restoration, the dog ban, and crucially, coupling that with sustained high-tech research and monitoring.
The drones, the scat analysis, the penguin trackers.
Exactly. Understanding those complex environmental feedbacks is key to adapting the strategies. It's not a one-shot deal, it's continuous management.
And the funding model itself is interesting, isn't it? It's largely driven by tourism,
That's right. Ecotourism is the engine. The wildlife brings the visitors, the visitor revenue funds the science and the protection efforts.
which leads to more wildlife success, which brings more visitors.
It's a positive feedback loop, a sustainable and hopefully replicable model for conservation elsewhere.
Yeah, it really feels like these animals, the seals warning us about the oceans, the bandicoots showing what happens when you remove invasive threats, they're more than just wildlife. They're living indicators.
They absolutely are. Indicators of ecosystem health and indicators of what focused, intelligent conservation effort can achieve.
It really makes you think. Which brings us to our final provocative thought for you, the listener. We talked about the koala thriving on toxic eucalyptus, something poisonous to almost everything else. So consider this. What other seemingly poisonous or difficult to access resources in nature might be quietly sustaining species we haven't fully understood yet? And what secrets of survival and adaptation might they hold?